Welcome to my talk about data modeling in Power BI Desktop, which I think is an underestimated task. My name is Marcus and I work with models. And if I tell people that I work with models, they have different perceptions about it. So some think I work with beautiful people. Instead, I work with beautiful data models like on the right. So what is the modeling thing? Let's talk about Power BI Desktop first. So Power BI Desktop was born as a self-service business intelligence tool. That means that the tool does its very best to help you in finding your way through getting the data, modeling the data, and getting to the reports the fastest and comfortable way. But has to do guesses because the tool cannot know everything about your data and how it is connected. So in most of the cases, this will work, but in some cases, there is potential for improvement, or in rare cases, it could be that your reports are wrong because your data model is wrong. If you're lucky, it's not really wrong, but only just slow. So, but it's really important that we think about the data model because a good data model is crucial for a good report. So agenda for today is I will talk in the next 60 minutes about relationships, denormalizing, data dimensions, and as far as we have time at the end for Q&A, or we will take a look into more advanced use cases. Let's roll and talk about relationships. A relationship is like a foreign key constraint. If we go to the model view in Power BI in a minute, we will see this is like tables and the tables are connected. And if you're familiar with databases, you will think suddenly that this is like a foreign key constraint because the table are connected. But in Power BI, we're not talking about constraints. A constraint in a database is making sure that I do not insert a sales row in the sales table for a customer which is not available in the customer table. That's what the foreign key constraint does. So it's doing something, preventing something in the sales table. If I do, if I want to insert something here, the filter constraint, the filter propagation in Power BI is the other way around. If I select or filter down a certain customer, the filter will make sure that I only see the sales amount of this customer. So it's working the other way around. When we talk about relationships, we will see that there's two possibilities of filter direction. One will be that the filter is going from one table to the other, or we can change this propagation to going both sides. And the other thing is the cardinality. So there's one to many. That's what we're looking for. In rare cases, think twice before you add something like that. We have one to one, and sometimes we need many to many relationships. But again, think twice before using many-to-many relationships. They can be dangerous in sort of performance, and that your model will work and return the right numbers. If I say one or many, one means of course 0 or 1. So it could be theoretically that we have a sales that we have a sales amount where we cannot find a customer for it, which would be bad data, but theoretically this is possible. And many also include 0, 1, or many. Doesn't mean that every time there has to be many sales for one customer. Some customer might only have one sales or even none sales. Let's go for the first demo. So I switch here to my relationship thing. And of course, we first go to the model view because we're talking about data models. So the first thing we're seeing here is a one-to-many relationship. So I have, let's close this down. We don't need this stuff here. So I have the transaction tables and I have a count table. And as we can see, the filter direction is going from the account to the transaction because we have this triangle with the pointy end going into the direction of the transaction. So the filter is going from account to transaction. If I filter an account, Power BI will automatically make sure that I only see the transactions for this account. We can also see that the column, which is used for finding the relationship or the filter, is the account ID. And we can also see that there's a 1 here and a star here, and this means a one-to-many relationship. So the star is a short form for many. And we can see that this one account can have many transactions. One transaction can only have one account. This is what the one-to-many is saying here. If we're going back to the report, we can see how this is work. working. So if I select an account here, if I filter an account, we can see that this account is now, the filter propagation is now going to the transactions, and I only see the transactions for this account, number 11. If I choose 12, I only see 12, and so on. If I select one of the transactions, so I select 11 here, it does not filter the account because we have a one-to-many relationship going from the account to the transaction, and the filter propagation is only from account to transaction, but not the other way around. I can hear you thinking and saying, Marcus, don't think we are stupid. If you select the account, we can see up there that this account table is filtering the transaction is filtering the account table, because if I change the account here, the account will change here. But this is a different thing. So we have a filtering in the model, but the report by default also has a feature called cross filter. So if I have one element on the screen on the report and I filter something there, it will automatically transfer the filter to the other elements on the screen on the report. So this is a different thing. This has nothing to do with the model. And this makes it sometimes hard to understand or hard to explain how the filtering thing is working. Let's take a look to another example. The one-to-one is really rare because we can see that one customer here has one customer detail and one customer detail has one customer here. They're connected with the customer ID. Usually you would just make one table out of that. A rare case could be if you have two different sources for customer and customer details, and you want to make sure that you can update those tables in different schedules. Then maybe you would opt to split this up, but usually would come up with just one table. As you can see that by default, always the filter is coming from the one side to the other sides. So as we have two one sides here, one-to-one relationship, the filter is going in two directions. So we can see there's two triangles and there's one point going into the direction of the customer and the other point, the end, is going to the customer detail. Then we have the one-to-many to one, which is not really the many-to-many relationship. It's just something in between. So again, we have the transaction tables and the account table. We already have seen there's a relationship here, one-to-many from account to transaction, with the filter propagation from account to transaction. And then we have another table here, account customer. And the account customer is also filtered by the account table. So that means if I select an account, both the transaction and the table account customer is filtered. But if I select something in the account customer or the transaction table, no filter is propagated to the other tables because it would be against the filter direction. As you can see here, we go to the report here, we can see if I select, for example, Jeff, then it will filter the transaction and the account customer table only for rows with the same account ID. If I select one account here, it does not filter the account table. We already have seen this. And as the account table is not filtered by the transaction table, of course, the account customer table is also not filtered by the transaction table. This is also valid the other way around. As the filter propagation is not done from account customer to account, no filter is done to transaction as well. And finally, we have the many-to-many relationship. And this time we have a bridge table. So we have like the many here, and we have now we have the many here and the many here. So I have one from the transaction to the account, and then they have one relationship from account to account customer, which we already have seen. And there's another one from customer to account customer. On both the customer is filtering the account table, as we have one customer having 0, 1, or many account customer entries here, and one account can also have 0, 1, or many account customers. So we have many on both sides here, and this is the classical many-to-many relationship. So one customer is filtering the account customer, and the account is also filtering the account customer. And we will say later in the case study, if you have time for that, how we can make sure that the customer is also filtering the accounts and the transactions, because currently this filter is not going through, as you can see here. So the many-to-many relationship is this one. So I have the account, and this is filtering the transaction, the account customer. I already have seen this, but not the customer. And if I filter the customer, it's only filtering the account customer, but not further to the other ones. And we will take a look on this later if time allows. After we have tackled the relationships and the filter in between and the cross-filter direction, next thing is thinking about denormalizing. What is denormalizing or normalizing? So if we think about a very Simple example. So if you ask me, Marcus, please give me a table with all the sales amount by product, which also shows the subcategories and the categories, I would give you one single table, probably an Excel spreadsheet, containing exactly that. One column for the product, one column for the subcategory, one column for the category, and the fourth column with the sales amount. This is a single table, and the single table has plenty of redundancy, because if one category, product category, has more than one subcategory, then the name of the category is appearing multiple times in this list. And this is bad. This is bad because things are replicated, so it takes up more space. And the other thing is that if I want to change one of the categories, and I forget about changing the other categories, then technically I have two different categories, which are real world the same thing. That's what we want to try to avoid. So applications which using databases to store their transactions, for example, if you think about bookkeeping or think about a customer relationship management system or Dynamics or something like that, they try to have a very normalized schema to avoid this kind of redundancy. And the keywords would be 3NF, like third normal form, or BCNF, boys caught normal form. And in the academic world, there's also fourth and fifth normal form, but usually for applications, third normal form is okay, where we try to avoid all the redundancies. So I would split up my example, having one table with the sales referring the product, then I would have another table with all the products referring the subcategory table, and then I would have the subcategory table referring to the last and fourth table, the products. So the thing is, the schema is split off. I end up not with one single table, but with 4 different tables. None of those tables have any redundancy, because one category only appears one time in the category table and is referred to multiple times from the subcategory table. But querying this stuff is really complicated. We have to write, if you want to query this in sequence, in select statements, you have to write join statements. You have to understand what a join table is. So the query is much longer. It's not just a select star from the single table, but a select from the one table, join to the other table, and so on and so forth. And the query, the performance of the query, the result will take longer, because also SQL Server or any relational database you're using has a more complicated stuff to do. It has to find out about the different tables, how they can be connected to each other. So this is slower. So for applications for OLTP systems, online transaction processing systems, like I said, bookkeeping, or like plain travel agency stuff or something like that, this is good, because they are writing very often, but read not so much. If you read much, then this is really a slow approach, and the best practice is to find something in between, to have a so-called denormalized schema. So we're not denormalizing to a single table, but we don't have the full normalized schema. And this reintroduces some of the redundancies. So yes, we're losing some of the space. And yes, we have like the problem, if we would update one of the categories and forget about the others, this would be a problem. But in a data warehouse, we have the luxury that there's only one single process updating the product dimension, for example. And this can be good tested, so we can make sure that if there's some changes, all of the currencies are changed. In such a model, we make a difference between fact tables and dimensions. So fact tables are all those tables where we have aggregatable stuff in it, and dimensions would be the tables with the filters. And we would distinguish between the star schema and the Snowflake schema. So star schema, one fact only refers to several dimensions, but the dimensions do not refer to further dimensions. In the Snowflake schema, the last thing would be allowed. So one dimension could have a foreign key to another dimension as well. So again, here is a single table containing everything there. There's fact, reseller, sales, large, a really stupid name for a table. And then we see this is a lot of, I don't have space for all the attributes here. So the first thing is all about the date, the order date, which happening is stored there, and this is a much longer list down there. As said, star and Snowflake schema, we would distinguish between dimensions, which contain all the stuff we want to filtering and group on. So we want, for example, only see values, sales amount for a certain year, and we want to group it by product category. The table compared to the fact table is relatively small, maybe a few hundred, few thousand rows, and it's always on the one side in our model, so it's filtering the other things. So there's one customer having multiple facts, for example, sales. The fact table contains all the aggregateable stuff like the sales and the quantity and the cost, and we would count over them. This is typically for facts, and they are comparable big, because usually we have a lot of transactions and they're stored then in the fact table. And in our model, they would be on the many, on the star side of things. Star schema would look like that. We would have the fact reseller sales table in the middle. We're just seeing one of the columns here, one table in the middle, the facts containing all the sales transactions, and then we would have one product dimension filtering. As we can see, the filter is going from the product to the fact table, filtering the fact reseller sales, also the time dimension, the date for all the dates. So we have orders, for example, or the territory would filter that. And with a little bit of fantasy, you could see that this is like a star. So there's the big thing in the middle, and then we have like the arms of the star. It's only a 3-pointed star here. Yeah, that's where the naming is coming from. A Snowflake schema would allow that we then distribute the product dimension into further tables, so having the product subcategory and the category there. As you can see, we would have less redundancy because the product category is only coming there once, not multiple times in the product table. But of course, we see the schema is much more complicated. It's not so easy to understand, and the performance will not be that good, because if I filter the category, it has first to filter the subcategory, then the subcategory has to filter the product, and then first we can filter the fact reseller sales down our sales amount. So when should you choose what? A Snowflake schema, as we have seen, has more tables, and more tables means that it takes longer to load. It makes filtering slower, and the field list pane will be less intuitive. So in Power BI on the right side, let's just switch back there. On the right side, we have all the tables here, and then we would only have, either we have one product, for example, this would be in the star schema. In the Snowflake schema, there would be a product and a product subcategory in the product category table. This is less intuitive for our end users. And hierarchies, if you're using hierarchies, this is not possible if the columns are coming from different tables. We have to bring them in one table to make hierarchies. So that would be the task to build a star schema firsthand. I tried a little bit around with a table on my laptop. So I have a database table with 18 million facts, which is not that much maybe for your systems you're working with, but for my laptop, it was something to do for it. And with, of course, with a single table, with one table in the schema, with a star schema, we would have 4, the fact table and the territory and the date and the product. And the Snowflake schema would have 6 tables in this example, because the product table is split up into the subcategory and the category additionally. What is really surprising, I think, is the single table. It's the same data for all the 3 schemas. The only difference is the schema. The single table takes up to almost 3 times of space on disk, and also, of course, in memory. And this is a bigger footprint, means also, of course, it takes up more memory, but it also means that the querying the thing will have the tendency to being slower. Then there would be extra space used for relationships. Of course, in a single table approach, there's no relationships, so it does not take any space here. As the model is rather small, the relationships also in the star schema, Snowflake schema, is way below 1 megabyte. So how can you build up your star schema or Snowflake schema? Of course, you use Power Query. This is the tool within Power BI Desktop to load the data and transform the data. Of course, we use Power Query to filter your data, to choose friendly names, to choose appropriate data types, of course. Hope you know that. And you can also use it to flatten your dimensions so that you load the same, the category and subcategory information into the product table, and you should not flatten your facts. The facts only should contain about all the aggregateable columns and the keys to the dimension tables. That's all which should be in the fact tables. The third thing, or I think I have just a little bit time, be good in time, so I can show you how you build the star schema. So, because I mean, it's easy to say build up a star schema, but usually you cannot define how your source system looks like. If you're really lucky, you can query a data warehouse, which already is a star schema, so this would be easy, but sometimes this is not possible. If your system is not in star schema, then we can go there to I changed to the new view here, and now I cannot find my way here. Recent sources, transform data. Sorry for that. So we open up the Power Query editor, and as we can see here, I have the dim product table. And if I load the dim product table, this contains only the product tables. The product category and subcategories in different tables in my source system, and I want to combine this. How can I do this? If you go to the very end, you see for all the foreign keys, you see the name of the table, for example, dim product subcategory. And if you click there, you see down there, what's the value here? There's a null value in there. This is not so interesting, but I think if you go down there, we should find a row which contains some values. Am I lucky? Yes, here we see. So this is like referring or showing me what's the appropriate dim product subcategory row contains. So there's the subcategory key, the internal key, the English product name, and so on and so forth. All the attributes are available here. And I can make use of this little guy here. So if you zoom in here to make it more easy to see you. So if you have this icon available, we can split up. So I can see what columns are there. And if I press OK, then instead of the dim product subcategory, yes, I want to insert a step here. Instead of the dim product subcategory, I get all the columns of the subcategory inside of my dim product table. And this is how I can access, for example, the subcategory name. And within the subcategory, I also have the category name and can make use again of the same trick to get to the category data. So this is how you can flatten your hierarchies within Power Query. So I will not save this one. And I should also close the other one, relationships, before we come into the, I'm lost here. Where is my, I've been here, normalizing, no, we have been here. So sorry for that. Yeah, Marcus date table. This comes first later. Date dimensions, that's the next thing. Agenda, date dimensions. So the date dimension is really, really crucial. One, for convenience, because your end users do not want to see only the date. They want to filter and group by month, maybe quarter and year. Some of them might be interested in weeks. So this is really a date dimension is necessary for that. And the other thing is, if you're doing time intelligence calculations, that means that you not only want to show the value for a certain selected month, but for example, if you want to have year-to-date values. So the February value should not show you only the value from February, but from January and February. That would be the year-to-date, or in March, it would be January, February, and March, and so on. And then it's really important that we mark the date table, as I will show you in a demo in short. The next thing is, again, Power BI Desktop is an end user tool, makes it as convenient for the end users as possible. So if Power BI Desktop sees that you have a date column, it will automatically create a hierarchy for you. But believe me, you do not want to have this hierarchy because this hierarchy is very inflexible, first. And the second thing is, it could grow your model really fast, depending on what time range you have in this date table. So my recommendation is to turn this off and come up with your own date table. Either you have a date table in a data source, for example, an Excel spreadsheet with all the dates, or a SQL query, or a data warehouse, or you could use DAX, the calendar auto functionality, to build up this data table for you. And you want this instead of the auto date time. And then we have this question, if we have multiple date references in our fact table, as we do in our example, how can I model this? And the two approaches is role playing or multiple tables, as we will see in the demo in a minute. So mark as date table. Do you have to do this? I would recommend, because it's really easy to do, and in some cases you would not need it, but in other cases you need to mark the date table if you want the time intelligence stuff working for you. How can you mark this? Going to the model view, mark as date table, and mark as date table, and then you have to choose which of the columns in your date table contains column with the date or date time data type. So let's see how this is working. So I've got a very simple model again here. So there's a model I've got here, and this model has two tables, really easy. So we have the sales with the date here, and this is referring the date column in the date table. And if we build up a report on that, so we see the date table here, we see the sales here, I can filter something and it's filtering there, and this is working. And so no surprise. And if I build a year-to-date measure here, what I'm doing here is I have the sales, I have a measure called sales amount year-to-date. And what I'm doing here is that I'm making use of the existing sales amount measure, and I'm making use of the calculate functionality. The calculate function allows us to manipulate the filter context. And I want to say the sales amount year to date should not just show the sales amount for a certain value, for a certain month, for example, but it should calculate the sales amount for all the days since beginning of the year. That is what year to date means. Let's have a look here. So if the simple example, we only have in month October, we have a sales amount of 48,000. We don't have anything in November and December, so the sum of the year is 48,000. If I have this year-to-date thing, then it will sum up not only the month, but the month plus all the previous months. I don't have previous months here, it's starting in October, but as we can see here, the November value is the November value of the sales, which is nothing, plus the sales amount year-to-date from the previous month, which is 48,000. The same is happening in December. At the end, it's only 48,000, so this is right. I do not expect that this is like 3 times 48,000. The year-to-date is working here. Then I do the very same with a different model. This looks very different. The only thing is that I'm using here a date key column to refer between the sales and the date table. And the date key column has the data type integer, whole number. So this is not a date column. And when we go to the reports, this is working as fine. So we have the same amount, 48,000, and I can filter here, and the filter is working. If I go into the year-to-date thing, I have the same calculation there. Year-to-date takes the sales amount and applies this year-to-date filter with the calculate function, but I can't see any values for November and December for the year-to-date. So what's happening there? The thing is, the date key is not a date column, and even if I'm using the date column here, the time intelligence is not working. So how can I change this? We're going to model. Now I have to find my way here. We're going to the date table. We're going to the date table, date key. And then I should have to change this to the new view. Where is it? Help, table tools. Here it is, mark as date table. Mark as date table. And then I tell Power BI that this is a date table and there's just one column of data type date. So I select this one, press OK, and as soon as we go back to our report, the date key thing is working as well. So my recommendation is always make use of the mark as date table so you don't forget it. And the best practice for dates is indeed to using like the date key in whole number instead of the date. But don't think about it, always mark the date table and then your time intelligence will always work as expected. The auto date time, this is what I and many people I know recommend to turn off. So how can you do this? In the options, you're going to the current file data load and you can turn it off for the current date so that this hidden table is not created. What's happening here? PowerPoint is missing with me. And if you want to make sure that this this time intelligence, this auto date time is turned off for all files you have on your system. Then you can turn it off in the options in the global option data load. So there's a data load in the global section and there's a data load in the current file. Turn it off for both and then you get rid of the automatic date time. I told you one reason is that it automatically creates date tables for you, and you can't see those date tables. You can see them, for example, I used the Vertipike analyzer from Marco Russo and Alberto Ferrari, which you can find on SQLBI.com. And when I analyze my model, my Power BI file, it will show you that there's like local date tables in here with different cardinalities. So obviously I have 1, 2, 3, 4, 5, 6 date columns in my model. And then Power BI automatically creates tables there. And you can see, depending on the date range of the table, this can be a significant amount of space used for those internal date tables. So my recommendation, turn this off. The next thing is if we have multiple dates in our system. So one way, as we can see here, there's the with the sales table and there's the order date. And then we have also the ship date. And as we can see here, I activated this link here. So this is yellow. We can see this link. This is an active relationship with a straight line is connecting or filtering the date on the order date. So the filter direction is going from date to order date. There's also an inactive relationship between the date and the ship date, which we will see in a minute. It's inactive, but it's still there. And the thing is, how can we use this? The solution is here, use relationship. Let's see this in a demo. So again, we're going to the model view, and then we can see that there is the date table, there's the sales table, and there's one active relationship between date and order date. And then we have this dashed line here, signaling this is an inactive relationship between date and ship date. And if I double click here, I can see, yes, this is the sales table to ship date to the date table date, and the cardinality is many to one. So many sales have one date. This is fine. And why would I have an inactive relationship? If I click there, unfortunately, I get a warning. You can't create a direct active relationship between sales and date because an active set of indirect relationships already exists between those tables. So we can only have one active relationship. So why would I create this relationship at all? The thing is that, of course, we can use this, and we can filter the date, for example, here. What is American date here again? So if we filter date, it will work, but it will only filter the order date part, not the ship date part. So if I'm filtering this down to the same date, for example, we'll see that the order date is influencing the date column and not the filter on the ship date. What if I want to see the sales amount for a certain ship date? We can leverage DAX for that. So I can create a DAX measure, ship quantity, which sums up the sales quantity, sum of sales of quantity from my quantity table. And then I can make use of the inactive relationship. So there's this inactive relationship we've just seen between the date dimension and the sales dimension over the ship date. And I can activate this in a DAX statement. I can or cannot also create an ordered quantity because the sales quantity automatically is filtered by the order date, but usually you would also create an order quantity measure to just match the ship quantity. And then we can see, yes, this is working. So we have the order quantity is showing us the quantities for the date interpreted as an order date. And then we have the ship quantity using the same date table, but interpreting this as the ship date. So we see all the shipping. So the order was there, and then the shipping was a month later. So the question maybe which comes up here is, why can I only have one active relationship here, but then go to a DAX measure and say this measure should be active? Now we would have two active relationships because there's one active relationship over the order date, and then I activate one in the DAX measure for the ship date. The thing is that DAX and Power BI is smart enough to detect, oh, the user asked me to activate this one. This would be in conflict with the other one. So temporarily, for the sake of the DAX calculation, I deactivate the other one. So for the sake of this calculation, only one relationship is active. The other way to model this would be to have multiple date tables. So for every date dimension, for every date column I have in my sales table, I would have a different date dimension. So I would have multiple date dimensions. One order date, one ship date, and they're both filtering on the model. So let's see how this is looking. We're going to the model view again, and then we see this is a different model. It's the same data basically. We have the sales table in the middle, but we have not only one date table, but two, one order date, one ship date. The order date table is filtering on the order date column of the sales, and the ship date table is filtering on the ship date of the sales table. We can build up different reports now because now we can distinguish and tell the system I want to filter on the order date, and I only see the order date for this month. This was too much. Okay, come here. So also here, I want to have the. I screwed this up. 19. This is not working. Why is it not working? Very cool. So now I'm filtering my order date. Here we go. Then I'm filtering my order date, and separately I can ship on my ship date. For example, I can show here. This is like let's start on the 1st of October, and then I start filter on my ship date as well. Come on. This is the first one, and both filters would then filter my date table. So one is the October thing, and the other is the ship date. Well, I can also build when I have two tables, two order date tables, two dimensions, then I can build reports like that, showing the order date on the rows and the ship date, for example, on the columns. And I can see that everything which was ordered on the 2nd of October was shipped on 2nd of November. Everything that was ordered on 3rd of October was shipped on 3rd of November. So that would be the different approach, different model thing we can use here. So I think I was really fast today, so we have time for use cases. Before we start the use cases, are there any questions, Kelly or Sandeep? Deepak, can you tell me if there are
no questions?
No questions?
Now. Yep, we are good to go now. Yep.
Okay. This is either a good sign that I explained everything really good, or a bad sign that nobody understood anything, so you can't even ask any questions. So let's take a look on the use cases. The first use case I brought here is, I call it budget. Typically with a budget is that the budget has a lower granularity than the fact tables. So we would have like, the facts would be like on every day, transactions on every day, but the budget is only on month level. Or we would of course have transactions for single products, but the budget is not on single products, only on product groups. This would be typical. The solutions we have at hand are those: treat as many-to-many relationship and building up a bridge table. So the first one is treat as. When I've seen this the first time, I thought this is a Greek goddess like Triatas. Before I found out this is treat as, so we can treat something as it would be something else. Let's go to the demo. I didn't close the thing here down, which is bad because then it's not opening up the next thing. So let's see, typical example for a budget. Let's go to the model view again. So what we've got here is we have the fact table is the sales here. So the sales contain of the sales amount, a day, the product ID, and the sales amount, which is a, I don't think we need this one now. So this would be a measure here. So there's the amount, date, and the product ID. The amount, the date is referring the date dimension. So the date dimension is filtering through the date columns of both tables. One-to-many relationship, again, filtering from date to sales. And the product table is filtering on the product ID. So there's a product ID in the product table and the product ID in the sales table. And the product is then filtering the sales there through the product. My budget would be more or less a different fact table. This fact table is filtered by the date, so I opted for a budget which is on the same granularity, which is also available in the date. Typically, this is not the case. It's just to make the things here easier. So I have one common dimension, but the budget is done on product group level. So one product group can have multiple products, which is assigned here in this one table. So one product has a product group. The budget is done on product group level. So the question is, how can we model this to make it successful? So one thing is here that we have the sales table, we have the product table, we have the budget table, and there's no connection, no filter between the product and the budget table. So if I filter the product table, I can see it will filter the sales table, but it does not filter the budget table. So when we have a report here having the months, so October 2019, I have group 1 here, and we have a sales amount of 33,000. If you take a look here, group 1 is product 100 and 110, and 100, 110 is the first 3 sales here. So 3 plus 20 plus 10, this is 33,000. This is working fine. Group 2 consists of 120 and 130 as ID, product ID. We only have a sales amount for 120. There's none for 130. No problem at all. The sales amount is 15,000. The 15,000 is what we see here. 33 plus 15 is 48. Wonderful. This is working out fine. What's not so working fine is the budget column here. So in the budget column, we see the same amount twice, 27,000. This is always something which should alert you. If you see the same number on different columns or different rows, probably there's something wrong with the model and the calculation here. And what people at least will complain about is that, like, we have 2 times 27,000 and the total is 60,000. And of course, 27 plus 27 is not 60. So what's happening here? The reason why these numbers are showing up is because there's no filter between the product table and the budget table, but there's a filter on the month level. So if you take a closer look, so the month is filtering the product table, but the group is not filtering the budget table. And then suddenly everything makes sense. So we have month 2019, 10, the October, and in October, we have 2 budget entries here, 2 rows here, and 20 plus 27 is the 27,000 we're seeing here. And then the line is repeated here for month October, but for the other group. But the group is not filtering our budget. Only the month is filtering our budget table. So we see again the 27,000 here. What about the 60,000? The total does not filter either on the month nor on the product group. It doesn't filter at all. So that's the sum of all the budget. And 20 plus 7 plus 25 plus 8 is 60,000. That's what we're seeing here. So the numbers make sense if you know how the thing is built and how Power BI is working. But for the end users, this would be like, yeah, silly to see the things here double. What we can make use of is make use of the treat as functionality. So we already have seen that we can have a sum of the budget, and we also already have seen that we can make use of the calculate function to transform or manipulate the filter context. So now we're making the sum of the budget, but applying a certain filter here. This filter is doing what? It's treating the values of the product group, so all the values in the product group, and applying them as a filter on the budget product group. So even if there's no relation between the product and the budget table, as we could see here, so between product and budget table, there's no relationship at all. There's no relationship, but we can do as the would sum. So treat as is building up a relationship within DAX, only this for the scope of the DAX statement on the fly. Even this is not available in the model. So this is helping a little bit. So it's helping that we now get an entry for 2019-11 for the second group, so 33,000. Unfortunately, we're having like, yeah, the budget is okay because for group 1 and group 2, this is the budget, this is the wrong column, sorry for that. So now we see that like we have the budget of 20,000 and 25,000 for group 2 and October and November. if we're going back to our report, then we see that for group 2, we have 20,000 and 25,000, once in October, once in November. So this is working fine, this part. But unfortunately, the group 3 is missing. So we also have a budget on group 3 for 7,000 and 8,000 for October and November. But group 3 is not showing up because here we're showing the group of the product table. So if I take a look here, you can see that this is like the group of the product table. The group of the product table. And in the product table, we don't have the group 3 because there's only group 1 and group 2 available. Group 3 is not there yet. What could we do? We could, for example, go in there and just assign or make up a relationship between the product group here and the product group there. If we do this, Power BI will discover, okay, there's the budget, the product group, and there's also product group here in the product table. It will just suggest a many-to-many relationship because there is like several groups coming here and several groups there. So there's not one of this table has a single product group only once, but both of the tables have the same group twice there. So it's coming up with a many-to-many relationship. If we do this and create the relationship, and then going back to our report, we can now see that also in the report without the 3 there, where we're just using the normal calculations, or like here, that now the budget and the budget treat is the same. So it's coming up with the same thing. If you're using treat as or the many-to-many relationship, it does basically the same. The disadvantage is still group 3 is missing. So how can we get this third group? And we can do this by closing this down again, so we can start up the next demo. And there is, where is it? Here's the bridge table. So what we have to do as a solution, what I did here, is to build up a so-called bridge table. So this bridge table is between the budget and the product and contains a list of distinct product groups from both the budget and the product table. And then we have like a many-to-many relationship, start here, resolved resolved as with the bridge table. So we have indeed only one-to-many relationships going from there and going from there. And with that, we get a report where the product is then filtering the budget table, as we can see here. Group 1, does it filter here? No, it does not filter. Of course, it does not filter. What I'm explaining here, it does not filter because the product cannot filter the budget. Only the product group is filtering the budget and the product. But we can see that we now get a list of all the groups, 1, 2, 3, and we get an according sales amount and or budget amount for the respective group and for the month. How can we build this bridge table? The bridge table is easily built when we go, for example, to, no, I did not build it in Power BI. I built this time as a DAX table. So we're going to tables, and in tables, you can create a table by leveraging DAX code. And this DAX code is exactly doing what I just described. Can I make this bigger? Yes, I can make it really huge for you. So I take the distinct list of the product group of the budget table. I take the distinct list of the product groups from the product table, union them both. So I get like a list, like putting those lists underneath, and then again, take a distinct list of that. Why all those distincts? Because one group, or there's many, the group 2 is referred many times in the budget table, so I only get it once. And of course, the group 2 is also available in budget and product, so I would end up after union with 2 times the group 2. So this distinct makes sure that I only have all of the groups only once, group 1, 2, 3, and this is what I can use to join the tables. So this means that sometimes we have to think about the model to come up with the right solution. Any questions so far, or I will show the multi-language thing? Deepak, are there any questions?
No questions, Marcus. We can continue.
Okay, whatever that means.
Yeah, the gang is so quiet.
The gang is so quiet. Okay, they're still shy.
Yeah.
So let's see about the second use case I brought. And second and last thing I will show you is the multi-language thing. So the solution for that is having one language table, having a choice of the languages for the end users. And this table is unrelated. And then again, make use of treat as, or we could use use relationship if we have an inactive relationship. And there's plenty of variations about it. I will just show you one solution for the multi-language thing. Oh, multi-language, here we go. What we've got here, I first show you, is it the solution? So what we have here is, there's, for example, I have the fact table containing an ID and 2 dimensions, and the dimensions like 11 is referring to this one, and the dimension 221 is referring to this one. So we're seeing like here in dimension 1 shows chair and blue with a value of 2. So this is this one. Chair 12 would be chair, and 21 is blue, and this is what we see here, and the amount is 2. And beneath, underneath, we have house and red. So 11 would be house, and 21 would be red in the English language. If I change this to Deutsch, which is German in German, then we would see Haus, Rot, Stuhl, and Blau. So you're also learning about languages. So house is house, that's easy. Chair is Stuhl, and red is Rot, and blue is Blau. Sounds almost similar. And of course, there's Österreichisch, which would be Austrian, but there's no Austrian language, so therefore we don't see anything here. So that's the little joke in here. Let's go to the model. How did I build this? So I have a detached table, a detached language table, which contains all the languages. This is what I'm choosing here from. So this is like showing me the languages from the language table, the language description from the language table, which you can see here. And this is detached. And of course, I could go there and say, hey, I have a language ID in the dimension, I have a language ID there, and I could filter this, and I could connect both tables there, and this is working fine. So the filter is now going from the language to the dimension, over the bridge table to the fact table. I would see the right thing. Okay, this is working. So I just learned this is working. So I take the language ID and move it over to the dimension 2 and put it also there. And then this relationship is only inactive. Why is it inactive? There's only one way from language to dimension there and to there. Why is it inactive? I think if we try to make this active, maybe we get a more hint. You can't create this between dim2 and language because that would introduce ambiguity between language and fact. So there's also the fact table there. And if we have 2 active relationships here and here, that would mean that Power BI does not know if I filter something here, if it's going down to the fact table, this path over dimension 1 and dimension bridge, or the other path. So this would be ambiguous. So this does not allow. So we cannot do this. So this solution is not working. So why is it working in my approach then? Because I'm using treat as. So with treat as, the model is really easy because we don't have any relationships. That's the wonderful advantage of the thing here. So if we go to the fact table, I've got my sales, and the sales is looking really, really huge. Thank you. So again, we have the calculate thing because we want to treat or manipulate the filter context. Then we have the sum of the fact amount. This is the easy part. And then we've got treat as. And treat as is then creating a filter between the language ID, the selected language is the selected language from the slicer here, filter down on the language table. And then the language table is filtering the dimension table on just those IDs. So this is how this is working. So, and this leads me to the conclusion that there is always, sometimes there's many possibilities. So one thing is, please take care of your model, because Power BI creates a model for you, but you have to review it. Power BI does not know everything about your data. You know more about your data, and sometimes Power BI could be wrong about that. So please check what Power BI created for you. And you should stay away from many-to-many cardinality, because as we have seen, sometimes you can create something, but you cannot add more stuff then, as you just have seen here. So we can create one relationship here, but not the other way, because we have this like going in different directions. So the one-to-many would go on in this direction, but as it is a both bidirectional filter, it's going the other way around, and that means that I cannot add the filter on both of them. So please stay away from many-to-many cardinality, and also stay away as much as possible from bidirectional cross filters. They make your model complicated, they make it harder to understand, they make it not so performant. Prefer the star schema. Take some time to think about it, how you can do this. And the second takeaway is that you always can exchange the complexity model for complexity in your DAX code. So as we have seen in some of the examples, for example, the date thing, either you have just one date table and then you have two measures, one filtering over the order date and the other one filtering about the ship date. So that the model is then simple, as it is just one date table in your model, but then your DAX is complicated, more complicated, your measures is more complicated, or you introduce two different tables for the date, one sale date and one order date, and then you don't need DAX to filter the tables either on sales or on order date. So that's the takeaway from this session. There's plenty of interesting stuff out there provided by Microsoft on docs.microsoft.com. I provide those links. I will put the slide deck immediately on Twitter, and I guess the guys from Microsoft will also post the video and the slide deck. And as soon as I know about it, I will tweet and show this on LinkedIn. So I did show you the relationships, how we can denormalize or how we should denormalize to a star schema, the date dimension, and then we have seen two use cases: the budget, typical for different granularity, and the multi-language thing, where you have to filter different dimensions on the same dimension on the language, which can be a struggle because there's no out-of-the-box solution yet in Power BI available. Again, here are the docs. They're really, really good. And are there any questions?
No questions, Marcus. Maybe like once we put that on the, hold on, I can see. Yeah, so they said like it's a great presentation and good job.
Thank you very much.
Yeah. So maybe once we post this on the YouTube, so there we can expect a lot of questions. So it will take, once we do the process post-production works and then we post it on the YouTube channel, then we can accept it. We can include a lot of questions and expect a lot of questions from the channel users.
Yeah, perfect. Just let me know about the link and then I will try to answer all those questions.
Yeah, awesome. It's a wonderful webinar.
Thank you very much. Thank you everybody for attending the webinar. And if you have got further questions, either wait for YouTube or shoot me a tweet or send me an email. Yeah, just let me know.
Yeah, thank you so much, Marcus.
Thank you. Bye-bye.
Bye-bye.